Welcome, everyone. I am just delighted that you have joined us for today's MTI Research Snaps webinar, Intelligent Speed Assistance, Can Technology Help California Stop Speeding? My name is Dr. Hillary Nixon, and I am Deputy Executive Director of the Moneta Transportation Institute at San Jose State University. MTI's mission is to increase mobility for all by improving the safety, efficiency, accessibility, and convenience of our nation's transportation system. We accomplish this through surface transportation research, technology transfer, education, and workforce development. MTI currently leads 2 competitively selected multi-university consortia. In today's webinar, we're going to explore how intelligent speed assistance technology might be a solution to the leading contributor to U.S. roadway fatalities, speeding. Our speakers today are Dr. Sahar Ghalipur Mashiani and Nushin Baradaran. Dr. Mashiani is an MTI researcher, associate professor in San Diego State University's Department of Civil, Construction, and Environmental Engineering, and the co-director of the San Diego State Smart Transportation Analytics Research Lab. She has expertise in traffic safety, driver behavior modeling, automated vehicles, and infrastructure-based safety systems. Nushin Baradaran is a graduate student research assistant and Master of Science candidate in civil engineering at San Diego State, where she specializes in transportation systems and intelligent vehicle technologies. Alongside her academic work, she is a full-time civil engineer in the land development sector, focusing on coastal single-family residential projects. Welcome, Sahar and Nushin. We are so glad to have you with us today. We are recording this webinar, and the link to view will be available shortly on our website and social media pages. Thank you all for taking the time to be here today. I will turn the floor over to Nushin and Sahar.
Thank you. Good afternoon, and thank you for joining us. Today, I'll be discussing Intelligent Speed Assistance, or ISA, and asking a central question. Can technology meaningfully help California reduce speeding? First, we start with the initial question of, what is ISA? ISA is an advanced driver assistance system designed to help drivers adhere to the posted speed limits. This usually involves GPS data interacting with accurately digitally mapped speed limit maps or in-vehicle networks to recognize this posted speed limit. ISA can range from a simple displaying the speed limit to a more intervention-based system that can provide accelerator resistance or even at moments intervening and restricting the vehicle's speed. There are 4 main types of ISA. Initially being the speed limit information, which is a baseline functionality and the driver retains full control. It intervenes by continuously displaying the posted limit. Secondary, it's advisory, which is an open system. The driver still contains full control, and it visually and audibly warns the driver as they exceed the posted limit. Third is voluntary, which is a half-open system, and the driver can choose to relinquish control and give the system autonomy, and in addition, overriding the system by applying more pressure to the accelerator. Lastly, there's an automated type, which is mandatory compliance, and the driver fully relinquishes control to the system, and the vehicle actively adheres to the posted limit. Why ISA and why now? Speeding contributes to fatal and severe crashes in the United States, specifically in California. ISA is widely adopted internationally, especially in the EU. This study asks 3 main technical questions. Is ISA reliable enough today to be used? Will U.S. drivers accept it? And what form of ISA is realistically scalable and applicable in California? We used a 3-pronged approach. Initially, we analyzed the NHTSA consumer complaints, which had about over 2 million records, and about 100,000 of those were related to ISA. And secondly, we analyzed the NHTSA recall database, which started out with around 300,000 recall records. Through our cleaning process, we ended up with 6,000 ISA relevant. And lastly, we designed and distributed a California driver survey, which examined the behavioral privacy, policy attitudes, and overall awareness of 286 licensed drivers. Through our complaint and recall, we determined that many of the key factors, key leading complaints or key leading recalls were related to speed, systems, or subsystems. For example, in our complaints, the keyword distribution, when analyzed, speed, engine, brake, control, and failure were a part of the main top categories. Additionally, California was ranked one of the highest distribution of complaints in our analysis. We assigned severity scores to certain complaint records because the respondents to the NHTSA database had an option to let people know if their complaint resulted in a crash, injury, fatalities, or towed. These were analyzed and put into a figure, which is seen in Figure 4. This gave us a sense of how these complaints would end up and what the results would be, but this was an optional portion in the database. In the recalls, vehicle control, accelerator pedal, service brakes, and equipment, vehicle control cables were a part of the top components in the recalls. Leading us to our survey. As mentioned, 286 respondents. We got 286 responses to our survey, which was distributed through mTORC and through the university outreach. Within the survey, we analyzed 8 different sections, which is indicated in Table 2. This gave us a sense of how California drivers would be open to ISA, if they had any prior knowledge to it, perceptions of how the system would help them, experiences with ISA if they had used it in the past, potential driving behaviors, what type of system they would benefit and like to see within their vehicles, and how policy support and regulatory perspectives would alter their views. And lastly, main point, privacy and data concerns that the respondents may have. In our survey, we analyzed that many people believe that ISA would improve safety and reduce speeding, but acceptance depended on the type of restrictions and the type of system that was being implemented. Many believe that ISA would help them in a behavioral aspect, allowing them to follow speed more closely, follow the limit more closely since they're being actively aware of it. And most drivers reported that ISA would reduce speeding behavior as mentioned. But acceptance would decline as ISA would gain more control of the driving aspect of it. Main topic was the privacy and trust. Nearly 80% of the respondents concerned about some sort of data collection. Nearly half said privacy concerns would affect their willingness to use ISA. Given the option of an open-ended response at the end, many noted that they were scared of what this data would be used for. Many assumed that it would be used as a motive for insurance companies to start charging them more, or a way for the government to have access to speeding behaviors and just in general knowledge and surveillance. Through cross-analysis, it believed that we saw that prior ISA experience increased acceptance of intervention-based systems, but ISA had to be trustworthy enough for the driver to use. The system had to gain the driver's trust in order to be able to be reliable. This was many noted concerns about the speed limit maps not being up to date or having a different speed limit in different areas. Many were skeptical of the effectiveness of ISA and how reliable the system design is. Some of the pre-submitted questions we got included of alert first, speed reduction second, can drivers be able to cancel it? The survey strongly was in favor of advisory and overridable capabilities within the system. As mentioned, mandatory had the lowest acceptance rate throughout the survey. Will drivers welcome added restrictions? Not universally, but once you gain the driver's trust through data transparency, system knowledge, the accuracy of the system, once the driver trusts the said system, acceptance will follow. Speed limits are ignored today. Why would ISA help? This gives the drivers a choice. It changes the choice architecture. ISA changes the driving default. It reduces unintentional speeding while still giving the driver control. A viable stack would first start out with a speed limit source, having a trusted and a reliable a map-based baseline, and sign recognition as verification in order to reduce false positives. Secondly would be gradual alerts, while optional speed moderation which would give the driver a sense of comfort. And lastly, validation in order to finalize and be able to calibrate to the finest map updates in order to have clear failure through the state. Through our survey, we noted that what would convince Californians in order to use ISA, it would be through advisory or supportive ISA with override options being clearly noted, and clear accountability through map errors, temporary limits, work zones, because this was noted many times through the open-ended of what if there's temporary obstructions in the road causing speed limits to change. Pathways in order to ensure success was having incentives through insurance companies rather than doing blank mandates, and proving the system reliability through pilot programs in high-risk corridors and integrating with already existing vehicle technologies. Through our study, it's clear that ISA has safety potential in the US through technical reliability and trust of the drivers. Advisory and supportive systems are the most viable options deemed through our survey and through the three-pronged analysis, and adoption will only succeed if autonomy and privacy of the driver is respected and the system has been able to gain the trust of the set drivers. ISA should be framed as a supportive safety system rather than a form of control on the driver. Thank you for joining us today, and if there are any questions, I'd be more than happy to.
Great. Well, thank you so very much, Nusheen. I really enjoyed hearing the compelling findings that you were presenting from your research. I'd like to once again encourage and invite all of our guests attending today to submit questions using the Q&A feature. But I do have a couple of additional questions. I want to thank you both for already answering some of the questions that folks submitted through our registration list. But I think one of the questions that I have is kind of how drivers adapt their behavior over time when using ISA. So for example, if you're a driver and you have an ISA feature in your vehicle, do you become safer, more compliant over time, or do we become more disengaged? And I suppose that depends a little bit on whether it is advisory as opposed to mandated. Compulsory, I think was the word that you used. I can't remember the exact word. But what evidence do we have about how drivers change their behavior over time?
So that would be done through further research, as in order to prior research indicates that drivers do, over time, decrease speeding. Many of the international studies indicated that through fleet programs, the drivers adhere to the posted speed limits more frequently than once prior. But in the US, especially in California, research is pretty scarce. Therefore, there's not any clear indication of California drivers, but internationally, through drivers in general, it does help through time, decreasing their ability to speed or their need, quote unquote, to speed.
So, but we got a question. It was submitted to us, and it's kind of interesting from one of our attendees. So when we think about certain rules along the road, we know that a stop sign, a stoplight is mandatory. We have to. If you go through those intersections against the green or against the stoplight and you are caught by law enforcement, you will receive a ticket. The same thing essentially is true with speed limits. I'm sure many of us here on the webinar today have had a situation where we have been stopped by law enforcement with as a result of speeding. So with these technologies, I mean, why shouldn't we simply mandate that if we have the technology that would allow people to better comply with rules of the road, why shouldn't we use it?
I believe it would be a sense of many drivers have a sense of control when they drive, and being forced and adhered to follow the posted speed limit would kind of endanger their control aspect, which isn't what many drivers are open to doing. As the autonomous vehicles are infiltrating the industry, many are choosing to go towards that route, but there are majority of people still wanting to have full control while driving.
So that actually segues really nicely. And Albert, I'm so thrilled that you asked that question because, yes, we all know that we have to stop at stop signs, stop light. We should follow the speed limit. But how does ISA perform during maybe, I don't know, emergency maneuvers, evasive actions, things like that? And I can think of examples where I've been on the road where I may have actually gone against what the rules would have said that I should do as a driver in order to avoid being in a crash or hit or something like that. So how does this technology behave when sometimes, I don't want to say we have to break the rules, but sometimes evasive maneuvers put us in a situation where we might be breaking rules because of what someone else might be doing? Sorry if that wasn't very clear.
No, that makes sense. It's in some situations you need to get ahead of the other side driver. Maybe they're driving dangerously, but in that case, it would bring up similar to how cruise control. You have the ability to just press harder on the gas, and it overrides the governor or the cruise control. ISA would perform very similarly to that, as if you just push harder on the gas pedal, it'll override the set system because the driver is taking full control. In terms of having the mandated the full system applied, there is override capabilities to that as well, which is what the survey and highlighted, that many drivers want to be able to override it in these emergency situations.
It's great. We've got another question, and this is kind of an interesting one that I think as well. And I don't know enough about the technology, but I happen to own rather old vehicles, and they don't have any technologies. I'm pretty sure I'm still manually running my window up and down. But are there retrofits or are there abilities to basically add on an ISA technology retrofit to older vehicles, or even maybe if someone's purchasing maybe a lower cost vehicle that might not have all the bells and whistles, that they could do this as an add-on or aftermarket technology?
There are ways, especially if it's one of the display type systems or half open systems. This is possible through a system that would just be attached to the vehicle's computer, since each car has a computer set inside them, and the system, it would require some modifications, but there are ways, and there has been research of being able to retrofit vehicles to fit the said system, especially if it's one of just the notification purposes. It's very easy to have a system to be able to display the posted speed limit.
Great. Pulling some of the other questions that we've been getting in the chat, I know there's a lot of discussion about the role of education and how can we educate drivers on the importance of driving safely and how dangerous higher speeds can lead to more severe collisions and other dangerous outcomes. Did your research touch at all on the role that education can play in terms of influencing driver behavior?
Directly, indirectly, we were able to gather information that if the respondents were educated about ISA systems, they were more willing to adapt and to adopt the system. It's only that when you know and gain knowledge about an item or about a system where you start to rely and trust on it. And that's our main goal with ISA, is to be able to gain the trust of drivers in the system. So there would have to be some educational studies done and educational proactiveness done in order to gain the trust and trust of the drivers. But
Yeah.
Sorry, go ahead.
No. I was saying, and I think that understanding how you use those technologies within your own driving, and I think that applies to many different technologies that we have in cars, and that understanding how they work, becoming familiar with them, is a really important part of the process.
If may I add something to that,
Yeah,
Hillary?
please, Sahar.
I think that's a pretty important subject. We had another project a couple of years ago that we actually looked at that gap that exists between what we have in the cars and what really the drivers are learning and getting their license. Yeah, so you go and get your license in a regular car, and then you get this high advanced with ADAS system, and there is this huge gap. So that study actually, we looked at what are some of the new training methods that we could have maybe inside the car with some videos, or it's not all time, nobody's reading manuals anymore. So we have to come up with some new ways for training drivers. And unfortunately, there is that gap existing right now. And you're absolutely right. A big part of the problems that comes up sometimes with these amazing technologies is that the drivers are not familiar with it and they just don't know how to use it correctly. Yeah, just wanted to add that.
So, you talked earlier in the presentation about the fact that you'd had evidence about how in EU or other international countries, they've been maybe more successful at bringing in ISA and maybe other similar technologies and having consumer or driver acceptance, but maybe not as much in the United States. And there's, I guess, I don't know, maybe call it the $1 million question that Alita poses in the chat. Why is it so much more successful, based on your research, in other countries at getting acceptance and adherence? And maybe we haven't had as much success in the United States.
In particular, in the EU, there was since 2022 and 2024, all cars are implemented and forced to have some sort of ISA systems, and this was done on the manufacturers themselves rather than the people. So any car that's being newly purchased would have this ISA feature. That's one method that they were able to utilize in gaining and producing mass-produced ISA system, like implementation. But in order to actually have the control and the acceptance of the drivers themselves, I don't believe that was vetted out.
Yeah. Sahar, do you have any insights?
I was gonna say this is similar to what we have for public transport acceptance. So it's kind of similar. So you'll definitely see a better public transportation and how people are using it in Europe. I think there is a big cultural difference. So culturally, here in US, people, they love their autonomy. So it's harder for them to just, accept the new technologies that they feel like it's compromising their autonomy. So I think we need to work on that a little bit more in terms of how we're accepting new things. It's a cultural thing.
Yeah. So I want to, and if this takes us a little too far from the conversation that we're having and your research, just let me know. But I was at a presentation at a conference in Washington, D.C. last month, and I watched a great presentation on some early stage indicators related to safety and crashes. And this one was specifically looking at hard braking. So, a crash didn't happen but there was a heartbreaking incident, so that you could think of, the more we understand about when and where these kind of behaviors are taking place, the better we could do at improving safety on the road altogether. So I'm wondering if you had any thoughts regarding some of those early stage indicators, or how we could use data like that to, address some of the concerns that we're seeing as to why we're thinking about ISA, I guess.
Mm-hmm. Nushin, is that okay if I take that?
No, please. Yeah.
Yeah, you actually mentioned a very new area of research that is recent. We call it proactive safety monitoring. Yeah, so instead of being reactive and watching the crash to happen, so a lot of time that's the traditional approach. So we'll just take a look at the crash history in the last 10 years or so, and then we'll figure out what to do. So this new line that you mentioned is called proactive safety monitoring. So let's, for example, take a look at how people are pushing the brake. Yeah, well, how is their behavior throughout their drive? How many times they push the brake? What are the situations? Or we have similar studies that actually we're running some cameras looking at the pictures and videos to figure out some safety surrogate measures like time to collision instead of the collision itself, or post encouragement time. And all of these new measures that we call surrogate measures, I'm sure they are going to help us much more than the traditional approach, just looking at the crash itself, which is a rare event. But this proactive safety monitoring is going to give us more data, and you'll have all of these data that could help with the safety monitoring and any intervention.
Great. Oh, that's fascinating. Sounds like a really exciting new direction in this area, which I think probably brings me to my very last question is, you've done this research. Where do we go next? What do you want to see happen, either with ISA or related technologies to help improve safety?
Nushin, you want to say that, or I'll go?
I can start, and then you please jump in whenever you see fit. But we had mentioned that implementing these in high-risk corridors would be one of the first steps in seeing how a controlled fleet of vehicles would interact with the system, and over time, how their speeding behaviors and speeding in general would change over time, since large-scale systems have not been implemented in California.
Mm-hmm. And I just want to add quickly that long-term impact that you mentioned at the beginning, Hillary, I think that's pretty important. We have a big gap there, so that would be something to look at. And also, there are some very limited studies on how we could actually adapt the system to the behavior of the driver, so it's more acceptable by the driver. So this is also something that I think that's very interesting, and we'll hopefully look into them in the future.
Oh, well, wonderful. So I want to make sure I am respectful of everyone's time. We promise you a maximum of 30 minutes. And so we are just about to wrap up. I definitely want to thank our speakers for joining us today. We have dropped a link to the final report into the chat, and it is certainly available on our website as well. And I'm certain if you have any additional questions, our research team would be happy to answer them, so you can reach out to them directly. And then one last note before you go. If today's conversation really sparked your interest in how research and data translate into real world applications, I would like to invite you to an upcoming webinar on careers in geographic information systems that's co-sponsored by MTI. The session is going to feature GIS professionals working across public agencies, consulting, as well as geospatial AI, who are going to share their career paths, day-to-day work, and insights into emerging opportunities in the field. It will take place next Wednesday from 12 to 1. I see that Alvarina has popped registration information into the chat. So Please join us or share with others that you think would be interested. And with that, thank you all for attending, and special thanks to you, Nushin and Sahar.
Thanks for having us.
Thank you. Have a great one.